Hi everybody. Today we are going to be talking about the angles of polygons. You should have already done the investigation activity that filled out the chart. If you haven't done that yet, go ahead and pause the video and make sure you get that completed. But if you have, this table should look pretty familiar. This table is, if you remember, basically the list of the different polygons that we're going to be talking about, and it related the number of sides that those polygons had to the number of triangles that were created from the diagonals, and then using those two criterion, we were determining the total number of degrees. So I just listed a couple of the boxes here of what you should have already on that investigation worksheet: the triangle, quadrilateral, pentagon, and hexagon. Notice that I listed the number of sides, so 3, 4, 5, and 6. And then after having drawn in the diagonals, we determined these were the number of triangles that were created. So for example, with the quadrilateral, we had to draw in one diagonal, and that created two separate triangles. And we knew from the last chapter that triangles are each 180 degrees total. So if this is 180 degrees and so is this one, we knew the total for all four-sided figures would be 360. And hopefully you were able to come up with a rule for those scenarios, a more general rule that can be used for any shape. And that's what we're going to focus on today, as well as exterior angles of polygons. So remember that I just said we have a relationship between the number of sides and then the sum of the interior angles. And hopefully you were able to come up with that general rule, but if not, this is something that I was looking for, or something very similar. This is what you'll see in your book: n minus 2 times 180, and this n right here is just the number of sides. So notice from the last table, the number of sides, if I subtract 2 from it, that's the number of triangles that were created in the picture. So that's where the n minus 2 comes from. And then the 180 is because we know triangles are 180 degrees. So this is the formula that you would use if you were looking for the total of the interior angles. So total interior angle measures. All right. And so in this first example, it says, find the sum of the interior angles of a 16-gon. So remember, this formula works for any number of sides. And all you have to do is plug in the number of sides and then solve. So here, the number of sides is 16. We're going to plug that in and get 16 minus 2 multiplied by 180. And that's going to give us 14 times 180. And when we multiply that out, we're going to get 2,520 degrees. So this would be the total of a 16 gons interior angles. And you could plug in 50 gon, you could plug in octagon, nonagon, any of those, and it will get you that total value. Now, using that concept, we can find the measure of missing angles if we are given equations. So in this example I've got here, I give you the parallelogram RSTU, and within that I give you equations for each angle. What you should notice is that the opposite angles are equal, which is actually going to save us a little bit of time. And we noticed also that it is a four-sided figure. So when you're solving for this one, you have to determine the total first, and that's going to be based on the number of sides. If you think back to the first slide, we know all four-sided figures have a total that's equal to 360. Obviously, if it was an 8-sided figure, our total would be something higher. Once you know that, then you're going to use your angle equations and set up one big equation and start to solve. So if I know my total is going to be 360, I'm going to add all four of these angles up and make it equal to that number. So adding these things together, I'm going to add 2 times 11x plus 4. Now the reason I put a 2 times that is because there were 2 of them, and then plus 2 of the 5x's. So obviously the way I'm writing this now is just to save us a little bit of space and time. You could have written out all 4 of them and it would have been the same thing. And now I'm going to go ahead and distribute. So I get 22x plus 8 plus 10x equals 360. Combining like terms, we get 32x plus 8 equals 360. and then we can go ahead and solve the rest of the way. So if I subtract 8 to the other side, I get 32x equals 352, and then finally divide by 32, and we get x is equal to 11. Now keep in mind that that was not the answer that they wanted. They wanted us to find the measure of each interior angle. So this is where you're going to have to plug in your solution. So if I plug in 11, I get for this angle 55 degrees. And for the angle T, I get 11 times 11, add 4, we get 125. And because this is a parallelogram, each of these opposite angles will be the same degree. And you can always double check your work. Once you've found the angle measures, make sure they equal the total that you set in step 1. So if I add up all 4 of these angle measures, I should get 360. And if I don't, that either means I plugged in incorrectly or maybe I've set up my equation incorrectly. So it's always a good way to double check your work before you move on to the next problem. The next example is focused more on our regular polygons. Remember from the investigation worksheet that a regular polygon is when all of the sides are congruent and all the angles are congruent. And the unique part about regular polygons is that we can find just one angle measure rather than having to just focus on the total angle measure, because we know all those angles are going to be equal. And to do that, the shortest way is to take the total interior measure divided by the number of sides. Obviously, this is going to change depending on the number of sides you're working with. So in example 2 here says find the degree of one interior angle of this regular octagon. So the key here is you got to know what an octagon is. It's an 8-sided figure. So that means Rn is going to be 8. And then we just want to find one angle measure. So I'm just looking for the one I marked here in my image. And to do that, I need to know my total interior measure. Remember the formula from the first part of the notes. N minus 2 times 180. That's the total for any polygon, divided by the number of sides. So if I simplify this, I get 8 minus 2 times 180 and divided by 8 because it's the number of sides. So do everything on the top first. So I get 6 times 180. That's going to get me 1080. That's the total of an octagon divided by 8. And that gets us 135. So what that means is that this one particular angle I'm looking for is 135 degrees. And if you look at your shape, every interior angle is an obtuse angle. So 135 is a realistic answer that we could use for this particular shape. So in one measure of an interior, make sure you find the total first and then divide it by the number of sides. Now, the next example here I have is one where you would be working backwards. So notice in this problem, it tells you the measure of one of the interior angles, but I want to know the number of sides that it has based on that degree. So this is one where you're going to be working backwards in order to find something as the opposite of the example 2. The key here is that you still use the same formula. So I put in green, remember that one interior angle equals the total number of total divided by the number of sides. Make sure you write that down because that formula you can use in pretty much any of these or most of them. So what I'm going to do is plug in everything I know from my example and then I'm just going to solve. If I know that 150 degrees is the one interior angle, that's going to go as my total for my equation. So I'm going to have 150 equals, and I know nothing about the number of sides. So my total equation is going to still be that n minus 2 times 180, but then I'm going to divide it by n because I don't know the number of sides I'm looking for. And now this is just a matter of solving. So remember, if we don't want a denominator, we can multiply both sides by that value and get it to cancel out. And what that leaves me with is 150n on the left side equals n minus 2 times 180. Next to solve, I'm going to go ahead and distribute the 180. So I would get 150n equals 180n minus 360. And now it's just a basic one variable equation where I can solve. I'm going to subtract 180n over to the left side, and I'll get negative 30n equals negative 360. And then, excuse me, when I divide by negative 30, I get that n is equal to positive 12. The final part of this section is about the exterior angles. As a reminder from the last chapter, exterior angles are found by extending the sides of a polygon. So I have a pentagon here in this picture, and I've extended all 5 sides to create my 5 exterior angles. And the most important thing you need to know about exterior angles is that their total, or their sum, is always going to be equal to 360 degrees. Doesn't matter if you have a triangle or if you have a 20-gon or a 100-gon, all of those exterior angles added together will always equal 360. And obviously, the more you have, the smaller the angles will be. So if you look at this example here, if I wanted to figure out the degree for each of these exterior angles, assuming this is a regular polygon, which means they're all the same sides and all the same angles, then all I have to do is take 360 and divide it by the number of sides. So this is my formula for exterior angles. And when I use that, I'm just going to plug in my n. So 360 divided by 5 in this particular example is going to get us 72 degrees. So because this is a regular polygon, that means that every single angle here is 72 degrees. And you could also use these exterior angles to help you find the interior angles. And this kind of goes back to chapter 1 in our semester, where we learned about supplementary angles and linear pairs. So if I know that this angle is 72, the one adjacent to it that's also supplementary is going to be adding up to 180. So I could take 180 minus 72, and that gets me that this angle is 108 degrees. So they're very helpful knowing exterior angles, especially in our regular polygons. The last example we have is just using that concept of exterior angles. Just for time, I'm going to go ahead and just have you guys solve for x, but I would encourage you to see if once we solve for x, if you can solve for angles A, B, and C and see how you do. But because I only want to solve for x, notice those are my exterior angles, and we know that all exterior angles are going to add up to 360. Now, keep in mind, this is not a regular polygon, so I can't just go ahead and divide 360 divided by the number of sides, because all of those exterior angles are different sizes. So instead, I have to set up a big equation. And before I can set up a big equation, I need to make sure I have as many of the exterior angle measurements as I can. So notice here I have an x, a 2x, a 3x, and a 72, but I could find these 2 angle measures here by just doing some quick calculations. So if I take 180 minus 134 in this particular angle, I'm going to get that this is 46 degrees because these 2 are supplementary. And then I can do the same thing up here at the top. I could take 180 minus 82 and get that this angle is 98 degrees. So getting those is just going to help me get my entire equation set up a little bit easier. And now I can go ahead and add all my exterior angles. So I'm going to have x plus 2x plus 3x plus 72 plus 46 plus 98. And all of those are going to add up to 360 every time. Combining like terms, I'm going to get, let's see, 6x. When I add 72 plus 46 plus 98, we get 216 equals 360. So then I can go ahead and subtract, and I'm going to get 6x is equal to 144. And then finally divide by 6, and I get that x is equal to positive 24. And of course, I could ask you then to find those missing exterior measures, and you would just have to go ahead and plug them into the 3 different locations. And then if past that, you could use those exterior angles to help you find A, B, and C. All right, so exterior angles always equal 360. The interior angles, you need the formula from the beginning. So if you have any questions on any of these or how to solve for a particular angle, let me know. But that's it for today. Thanks for listening.